So hello, we are recording. And so what we are going to do today is I'm going to kind of walk you through an example for homework 3. And so in order to do this homework, you are going to need SPSS as well as your books. So this is an assignment that isn't just pure SPSS, right? So, or calculations, you're going to actually need to use your book for this. So without further ado, let's do that. So let's look now at, actually, let me go back. I'm going to share my screen a different way so you can see the output. Okay. So what you should have here is an SPSS data file. And so we're going to pretend that these are the scores for participants for people in the class when they had a video like this versus when they didn't have a video like this, right? And so it's the scores on some assignment. And so you guys probably know how to get the, Zoom always puts all this junk in my way. How to get the z-scores. So it's pretty easy. We just go to data. Oh, sorry, to analyze, to descriptive statistics, descriptives. We're going to pull over the variables that we're interested in this case, the video and no video columns. And then the important thing is that we click this. It saves standardized values as variables. So a z-score, another term for it is standardized value. And so I'm just going to check to be sure that that we're getting like the mean and standard deviation there. And so I'm going to hit OK. And so you will get an output file. So does everybody see my output file?
Yes.
Yeah. Good. Yeah. Okay. Yeah. So you get the output file where you get the means and standard deviations, but what's really important here is that your data file is going to add some information. Right? So you see there's 2 new columns here, the z-scores for video and the z-scores for no video. And so what a z-score is that person, so this is person number 3 here, this person's personal standard deviation from the mean, right? So we've talked about standard deviations in terms of a sample, right? So we've calculated sample standard deviations. What we're talking about here is that participant 3 scored a 93, and that is 0.662 or 0.663 standard deviations above the mean for that group. Now, we're making a lot of assumptions here when we're talking about z-scores. We're assuming that this sample is normally distributed, that the data for the sample is normally distributed, which it isn't. Right? And so that's why sometimes it doesn't totally make sense when you look at it, when we're dealing with these tiny, tiny samples that I'm giving you as examples. But generally, if you assume a totally normal distribution, you can say that the z-score is that person's personal. So like, for example, this guy got an 88 in one condition and 84 in another condition. So in the first condition, he was 1.7 standard deviations below the class average or the sample average on this test. However, he had an 84 on the second, and he was 1.38 standard deviations above the class average for that test. And so that's what z-scores are. And I think most people can get that far. Now, the second step, oh, here's the chat thing here. I'm going to stop sharing my screen just for a moment. Okay. So the second step to this is, say that we've got this number 5's z-score. And so for his condition where he was under minus 1.7 standard deviations from the mean, what we do is we look up in table B1 in our books. And so that's on page 355 for the current edition. It'll be in older editions and it'll be in just about any stats. Oh, I can't do that. That's annoying. I don't really know how to do this, but okay, it's on those pages. And there's examples in your lessons as well. I wonder, I don't want to spend any time on that. I'm going to see if I can take off that stupid background. Well, I can't easily do it, so we're just going to live with that, right? So anyway, you're on page 355. And so you look up 1.70. So basically the absolute value, whatever that is. And so if you look at 1.70 under the z-score column, you find next to it that the area between the mean and that z-score is 45.54. 45.54. And so just going to share my screen here a bit. So remember this, that's our lovely depiction of our bell curve, right? The mean is here. And remember when I said you are really going to need to memorize this. I should have drawn this out before, but I didn't. Okay. So where it's 34.13% on either side. Now, I hate that I'm so bad at this. All right, try again.
It looks great.
Thank you. I needed that, right? That's 34.13 about, right? So on each side, so within one standard deviation on each side of the mean, it's going to be about 34.13%, you know, and so this is a standard deviation on that side, a standard deviation on this side, you know, and then, you know, we know that it's, you know, about 68%, 2 standard deviations, you know, taking, or 1 standard deviation on each side, 95%, 2 standard deviations. So that, I can go back to it in the lesson, but that picture of that bell curve with the percentage of people in the sample that fall between a standard deviation and the mean, you should basically memorize that, or at least have that very handy on your next test. So actually I would memorize it, to tell you the truth, especially if you want to go to grad school, you should memorize it. But okay, so we know that. So now the question is, we know how many, the percentage of students who fall between 1 standard deviation. Well, what about 1.7 standard deviations, right? So we'll call this guy Tom, got negative 1.7 standard deviations below the mean, right? So he's kind of like way out here. Well, how do we figure out what is the percentage of students between Tom and the mean for the whole class? And it turns out all we have to do is look it up on that handy table on page 355 of our books. We know that 45.45, is that what I said? 54, never mind. 54% of that sample scored between Tom and the mean. So if I ask, you know, it's kind of an easy question, what percentage of the sample fell between participant 5 and the mean? The answer is very simple, 45.54%. However, I might ask it a different way. I might ask how many fell between Tom and below, right? How many people scored below Tom? So what's the percentage of the sample that scored below Tom in this case? And so that is when it is really good to actually draw this bell curve out. And it's a pain. I know you are taking a test or doing your assignment and you want to get through it as fast as you can, but believe me, this will help. So you draw out this bell curve, you know that there's the mean, and you know that here's Tom. Oh my gosh, why don't things just read my mind and do what I'm thinking instead of what I tell them? Right? Ah, I wanted that to be blue. I want a blue pen. Okay. So we know that Tom is somewhere over here, let's say. All right. All right, no more frustration. Here's Tom at 1.7 under. Okay, so, and we know that this is the area right, between Tom and me. Just cracking myself up. I've had a lot of meetings today, so I'm just gonna go with my feelings now. Cracking up at this point. This represents the 45.54%, but that's not what I asked for. What I asked for is how many, or the percentage of people who were below Tom. I asked for this, right? So that's below Tom. And so you can see there's a discrepancy there. Now, what do we know about the perfectly normal distribution? The mean and the median are the same, right? Yeah. The mean and the median are the same. And if something's divided down the median, what is the percentage of students, or the sample, sorry, who falls below or above that?
50-50?
50%, right? So in a perfectly normal distribution, the mean and the median line up perfectly in the center, and exactly 50% of the sample will fall below the mean, exactly 50% above. So we know that it is 50%. Oh my gosh. Yeah, above and 50% below. I know I said opposite words, it's fine. 50-50. So what do you think we do now? So I asked for this, I asked for the red part, you only have the blue part. What do we do? What do we do?
Subtract it from 50.
Yes, that's exactly what we do. We do this. Yay. And so I'm obviously too zoned out to do that math in my head. So I'm just gonna ask my calculator. So 50 minus 45.54 is 4.46. So poor Tom, or Ralph, or whatever I called this guy. Oops. He only scored above 4.46% of the sample. That's sad. But what if I asked, what is the percent of the sample that scored above him? We have that, right? We still have him down, way down here. I mean, not that far down, but you know, maybe about here, right? It's still true that your book is going to give you in the table this. It's going to be 45.54%, but I want to know the percentage of people who scored above Tom. What do we do?
Add it to 50.
We add it to 50. See, you guys didn't even need me in my
Oh, we do.
terrible handwriting on whiteboards. I think there needs to be a class for teachers on how to do that. Write on these things. All right, so we will get 95.54% above Tom's score in this sample. So that's how you work those problems. You can also do it on the other side. And so we'll do that. So this guy, Tom, I'm calling him, got that 84% in the other condition. And that is 1.37 above the mean. Yay, Tom, he did much better on this one. So at least compared to the class. So he's probably about here. Well, that almost looks like 1 standard deviation, but we're going to pretend it's 1.37. It's actually 1.38 when you round correctly. And so it's 1.38 above the mean. So what's the first thing? So I want to know how the percentage of people in the class that scored below Tom. Anybody know what I do first?
Look in the book and find,
Yep.
I don't know what you call it, but that number that
The
goes.
z-score, that's right. Yes, this is Tom's z-score, right, which is 1.38. So that's his personal standard deviation. And so 1.38, when we look that up in the book, we find that, I'm going to switch pens because I swear I think that this is helpful. So that is 41.62% here, right, in this area between Tom's score this time and the mean. But that's not what I asked for. What I asked for was how many below Tom. And so what would we do now?
Do we subtract?
Say it again?
We subtract?
Add it to
No.
50.
Yeah, so we wouldn't subtract this time because this time we're on this side of the bell curve. We're on
Okay.
the good side, the high scoring side, right? And so, to get to that, so we know that this is 50%. That's why it's so good to write this out. When you do I tell my students, when you do these on and your assignment too, but you kind of have more time for the assignment on the test. I think some students think like, oh, I don't have time to kind of write out this bell curve and, think it through like this. You do, like, it'll definitely actually save you time and confusion if you actually write this out and say, okay, this is what Dr. Witten asked for. She asked for this whole area here. This is what I have. Okay, it's very clear to me that I need to add 50 in this. Whereas before it might be, if you don't write it out, you might get confused and end up subtracting it when you were meant to add it, or vice versa. Right? So I know that this is the handwriting of a serial killer child somehow, but you get the point.
That description.
Yeah, right. Like if there is ever a class for how to, like I can almost like color and draw on these better than I can write, just making numbers and letters somehow eludes me, but I think that you guys get the idea, right? So at least more than doing nothing for sure. So there's that, but there you go. So what would we do to get, like, if I asked for instead of who scored below, let's say I asked for who scored above him, that's the green part, right? What would you do? 50%, right? What would you
Make
do?
it minus 100.
Well, you could just take this, since you've already calculated this, you can absolutely subtract 91.62 from 100. So that would work too. But let's say that you hadn't calculated that already, that you're kind of starting with this information. You would just
Subtract.
Yep, that's it. And so you get the same answer either way. Oops. Oh no. decimal point. Can you see my calculator?
No.
Oh,
No,
you can't. Okay. So you can
you
I
just see your mouse clicking around.
That's funny. Okay. So that is basically how you approach your homework for this lesson. Does that cover the questions that you've had
Well,
about?
I understand that portion of it. Say for instance, maybe I'm confusing myself, but let's just say like you asked a different way, how many standard deviations below whatever number you just used. How am I calculating that? I think I am really confusing myself.
Yeah, it sounds like you're overthinking it because it's always going to be the same no matter what the example is. So just abstractly, right now, let's say that we don't even have to run any SPSS. So anytime you have a normal distribution is kind of the caveat there. But anytime that we say, okay, all right, I need a new page or not, who cares? It's fine. Anytime we say, hold on, it's driving me crazy. I'm going to erase all this and start fresh. I'm not allowed to start a new page. Apparently I've hit the page limit on the whiteboard. Great. So imagine now that Joe Schmo or X or some random person, I changed this already. Oh, that's why. Okay. Just anyone random got a z-score of that. I just made that up, right? In any context, it's the same. Assuming a normal distribution, a z-score of 1.57 is going to be able to be looked up in any z-score table in any stats book. Yours is on 355, but this is basically the same table in all the stats books. And so between the mean and that z-score is always going to be 44.18. So you figure it out exactly the same way, no matter what. So if you want to know, okay, it's a pretty low z-score, how many scored above that in any normal distribution, you can write that out. We've got the mean here. We've got this person's z-score way over here. We know that this area is the mean between the z-score and the mean. And we know that that is the 44.1. Oh my God. 44.18. Wow. And I asked for how many scored above him. So you know that I need, I think my mouse is doing weird things. I'm gonna go with that, right? So we know that we need to add this whole 50% to this for our grand total of 94.18. So 94.18 scored above this person. So does that kind of make sense, Letitia?
It does. I think just when it says how many, wait, let me see. Just when it asks how many standard deviations below or above whatever number, I'm just confused, or are we actually putting that z-score or not? I'm sorry, not the z-score, but whatever answer that we get once after we calculate.
Well, I'm not really sure what question you're referring to, so so that may help, but all that the z-score is how many standard deviations that individual score is from the mean. Okay. So we talked in the first lesson about the standard deviation for the sample. Now we're saying, like, let's say the whole class, scored something and had a standard deviation of whatever, right? But now, Melissa, so who's the first person on my screen, so that's the only reason I'm picking on Melissa, had a z-score of positive 2.8. Wow, Melissa, that means you scored 2.8 standard deviations above the mean. Let's say some random person in my class, I'm not picking on you, because let's say that they had a z-score of negative 0.8, then random person had scored 0.8 standard deviations below the mean for the class.
I have a question about the negative
Okay.
thing. So in my last statistics, sorry, I was on mute. In my last statistics class, I had like a positive z-score chart and a negative z-score chart, but in the book it looks like it's only positive. But in the homework, hey, go. In the I'm gonna have to hide. In the homework, one of the ones, like it says like the mean is like 33 or whatever. Anyway, I got like a negative z-score number for it. So I'm not knowing how to like find that in the book.
Yeah, so there are different kinds of tables for these z-scores and the percentage. So some, instead of making you add the 50 or subtract from 50 yourself, just give you that number, right? So it would say like, okay, it's 44% between the z-score and the mean, and it's 94% above and whatever 16% below, right? So it kind of gives you all the scenarios. You don't kind of have to adjust for the negative or the positive, right? So for us, we only get the percentage between the mean and that particular z-score, right? So we have to say, that's why I think writing it out is especially helpful. So we have to say that, okay, if you get a negative z-score, I hate not having a fresh page when I need one. So if you have a negative z-score, she says again, you look up in the book just 0.8, just the because it's going to be the same on either side, right? So if we're looking at, again, our lovely depiction of the bell curve, the percentage, wow, okay, that's even too bad for me. All right, whatever. So 0.8 on either side of the mean is going to be the same percentage on either side, right? So whatever it is, going to 355.
3.19.
Thank you. So I'm not even gonna color. It's gonna be 3.19 either way, right? Whether it's above or below. So that's why you can just kind of do the absolute value, but you need to know that because you are looking at 0.8 below, that what you have is this section. And so it's going to change. I mean, obviously, if I just ask between that z-score and the mean, you just need to say 3.19. But you need to know, if I say below that z-score, right, but below this score, what's the percentage of people below the score? Then you need to, you need to subtract from 50, because what you actually need is this area over here. In contrast, if it's a negative score and I ask you what the percentage of people who score above, you know you need to go get all of this area here, not that area though. The blue, oh my gosh, the blue part and the, yeah, I'm going back here. So does that make sense? It's just that you in your previous class got different charts, got kind of more extensive charts, but here you only get the percentage between the z-score and the mean. And so you just kind of have to know, okay, if it's negative, this is the area that I have this little area under the mean. And so if the professor asks, or I need to know what's below it or what's above it or what's below, I need to add or subtract accordingly. Does that make sense?
Yes. So just to be clear,
Sure.
so say I had a z-score like that, the -8, for example. When I go to see the area between the mean and the z-score, I don't need to immediately put a negative on that too, right? It'll still
No,
be
not at all.
okay.
So
Okay,
that's
okay.
just not at all, because that's just the percentage, right? That's just the percentage of people. It's kind of like saying, you know, like if I was report, okay, you know, 3.19% of the class scored between you and the mean, you know, it's just a percentage like that. So there's not really like a negative percentage like that. Does that make sense? It's just,
Yes, yes, I'm with you now. I just was like, I can't even find that other chart.
right, yeah. So I know that, so different books would present it a little bit differently, but the numbers are always the same. Like those percentages beneath the z-score are always the same. So it's just another way of kind of looking at it depending on the book. Okay. Any other questions about this that can help you understand this in the homework?
I wrote down a question from a practice quiz, and unfortunately I didn't open it back up to see exactly what but I wrote, does magnitude equal the R value? So this was back on practice quiz 3, back a couple of lessons.
Okay.
I hope it's
so
okay if I ask that right now.
it's absolutely fine for you to ask that. Yeah. So when we talk about a correlation,
Yes.
so R is the correlation coefficient, right? So R is what we mean by when we say the calculated correlation, right? So it's what you get from SPSS or if you calculate it. So so we can have a correlation coefficient, and I'm just gonna go back to the whiteboard because I'm gonna get comfortable with that one of these days. Nope, that's SPSS, never mind. It's definitely partly my mouse. I gotta do something about that. So let's say that we calculated an R value of -0.81. Okay, so there's two components to any correlation coefficient, right? So R just represents the correlation coefficient, which is the -0.81. So the first is what we call the valence, or, you know, basically just the sign, positive or negative, the direction, which says, you know, if they're both going up at the same time or if one goes up and one goes down. And then the magnitude is the strength of the correlation, right? So regardless of the sign, how strong is that correlation? So we can look at the 0.81 to see, okay, is the closer that is to 1, right? Or if you want to think of it that another way, the absolute value of 1 for the whole correlation coefficient, then the magnitude is strong. The 0.81 is a relatively strong correlation, right? In terms of magnitude. So does that make sense?
I think so. I just wrote on my notes, does magnitude equal the R value? But I think that's what I needed to know is if you're looking.
Yeah, so it's
to
not
R
really,
value.
it's part of the R, it's the strength associated with the R value is how I would say it, right? Because we're making a distinction between direction, which is the sign, and magnitude, which is the strength. So magnitude just has to do with the strength of it. So like R equals 0.02, right? So the direction would be positive, but the magnitude would be, I mean, we could say 0.02, but the magnitude would be relative or very weak in this case.
Okay, I gotcha. Thank you so much.
Yeah, so hopefully that helps you think that through just a bit.
Definitely. Thanks again.
Yeah, no worries, no worries. Any other questions about anything really? Your assignment coming up, or questions on the practice tests, or anything that I can help you with at this time to understand the material?
I actually have another one if nobody else has one.
Absolutely. That's what we're here for. You might as well, right?
I know that there hasn't been a lot of focus on using Excel, but I'm
Right.
finding that it says to use a data analysis tool. I don't have it. I can't install it. I'm really struggling. Should I be worried so much about this, not being able to make this work with Excel, or?
You do not need to worry about that for future assignments, right? So it's all going to be SPSS now in this class, right? So I would say that Excel, one of the main reasons I have you, well, there's a couple of reasons. I have like 1,000 teacher reasons, but one of the main reasons I have you use it right at first is because when you're going through your assignments and your exams, it's a really good way to check yourself. Right? So for example, if I give you something to calculate by hand. All right, so my cat just had a shit fit. That was great.
Oh no.
Just randomly, I guess because it started raining, maybe, I don't know, but all of a sudden it just did the thing where he just did a little meow and just ran frantically that way. Pretty crazy.
Oh,
All right. So that's why I was like,
you must be feeling better.
Oh no, my other cat passed. So
Oh, I'm sorry.
yeah, I know it was really tough, but it's okay. We're doing okay. That's Macklin over there, named after Burt Macklin, FBI, if anybody's a Parks and Rec fan. So yeah.
That's so great.
He's my little Andy
I love
Dwyer, I
Parks and
swear.
Rec.
He's just like, he really has Andy Dwyer's personality. And so I know this isn't the point of this, but I also have another cat because I like, if there's a sick cat somewhere, I'm just like, I'll take care of it. But I have another cat named Rory, Gilmore Girls. So Rory is a black cat, and I swear to God, she could be the incarnation of April Ludgate. She's definitely like, I am going to go off by myself and do my own thing and can give those wonderful scathing looks, but they do not get along at all.
Oh no.
I'm
You should
like,
have named her
Andy and
April.
April, you should love each other. Come on. You should get along despite your differences, but it doesn't happen. So anyway, that's my segue into my life with cats. That's very interesting, I'm sure, for you. But okay, so the question was with Excel. So when you are performing a calculation, for example, by hand on your exam, you can always check yourself using Excel. And I do want you guys to get in the habit of doing that. So I think that it's unfortunate for you. It's kind of like you're missing a tool to be able to check yourself and process this statistical information. So I think for your benefit, and it'll come up again in research methods, I would try to work it out, to where you can maybe have access to that program, but you won't be submitting any more assignments using Excel. So
Okay, that helps. Yeah, I'm not sure. I went through all these YouTubes and it gave you these options to download it, but neither one on
Mm.
mine had that. It said no option to install is what I wrote down. And so I don't really know.
Well, I would get with IT because we have it for through UCF apps.
Yeah, that I
This is-
used that one and then my own. And both of them,
Yeah.
there was like a step where it would say like an add-on option.
Hmm.
And it didn't come up, but again, I'm not super savvy, so it could definitely be user error for sure.
Yeah. So I mean, that would be something I would look into, and do be mindful, just kind of a global. I mean, this may not apply exactly to that because I don't really know what's going on with that, but just be mindful. I know that it's difficult to work with. It's kind of difficult enough to work with SPSS because it's new, but I know that it adds another layer of difficulty sometimes working through UCF apps. And I'm sorry for that, but you guys do pay. I mean, it's not free, for you guys. You pay a lot. I mean, if you look at your tuition fees, you pay a lot of money for these programs to have access to these programs. And so I think that it is important to kind of, I mean, you're not being a pain in the butt when you're asking questions, when you're going to IT and asking about that, because I mean, it's your money and it's your education. I mean, part of what we're trying to prepare you for, and one of the explicit items like I'm mandated to teach you is kind of technological proficiency. And if you look at NACE competencies, which is what employers look for and graduate programs look for in graduates, is a technical competency in technology, basically. And so it is important for you. I mean, it's not just something I like to do to torture students, because believe me, I get tortured just as much when things like this don't work, but it is really important for you to learn these programs, to be able to think through what these programs mean. And so when you have these obstacles, it's important that you inform people about it. Definitely contact IT, make them fix it. I know I feel bad for them too, because I know that they get a lot of student complaints and stuff like that, but especially when it comes to this program. But like, it's your education and it's your money, which is as important, I suppose. But yeah. Anyway, that's my little spiel. I know I've said this spiel before, but I'll say it again, I'm sure.
I appreciate that. I thought it was just me, but I'll try to pull it back up and then actually have him on the phone, IT on the phone when I do it. And
yes.
see if
And
I get somewhere.
one good way to get through IT, and I know this is one of those things that I just kind of know, so I do it this way. So I don't really think that other people would, I know I had a student who was emailing IT and not getting a response. Go to that place in IT. As a matter of fact, it's so important. I'm going to show it to you. Like, actually submit a ticket to them. I swear that is the best. Wait, can you guys see my Google coming up?
Yes.
Yes.
Google is, oh, it's raining here, so it's refusing to connect. So let's see if this. Okay, it's coming up. Sure. So go here to submit a ticket, and you can fill out everything there.
Okay.
No, it's not. Yeah. So, okay, yeah, my internet's a little bit wacky, I think, but yeah, you'll have to log in and stuff like that, but never mind. But you saw where it is, right? So go and do it that way. And I think like that's the usual way for them to process and communicate these kinds of issues. And so usually what happens, like if it's something where they want to talk to me, like they'll set up a meeting with me either over the phone or through Zoom or what have you. But sometimes they can just, I mean, they have a lot of this knowledge. That's why I always encourage you to go through it. Just like if you describe, oh, my Excel is doing this and this is the error message I get, they'll just say, well, I don't know, like restart it and turn around 3 times and, pray to Buddha or whatever, you know what I mean? Whatever magic thing that they have. And you'll go like, okay, yeah, that worked, so a lot of times it's a really easy fix, even though for us, we're not used to thinking through problems like that, from their perspective. And so we'll go like, I don't know really what to do. This is a new error message for me. And they're like, oh yeah, that error message, all you have to do is X, Y, and Z. And you're like, okay, that worked. That was easy. But sometimes it's more serious and they will set up a phone call with you or a Zoom meeting with you as soon as they can. So
Thank you. I needed that yesterday, but thank you, because I had no access.
Exactly. A day late and a dollar short, but thanks.
Yeah, I had no access at all under UCF apps. Nothing was there.
Oh, no.
That's awful. Yeah, I know. It's, I mean, it is what it, like, I think that the truth is, I'd like to say that, yeah, it stinks when you're a student and, you know, you have these problems and stuff, but it's always going to be like that. I hate to say that technology kind of has its own, you know, will, I guess, if you want to look at it that way. But, you know, there's always going to be technology problems. And I think that one thing to really learn is how to handle it when technology isn't working well. You know, and I think in future classes, I'm really going to maybe talk to my students more about that, like in a professional situation. You know, it happens all the time where technology doesn't do what you want it to do. And when that happens, how do you handle it? You know, who do you ask? Where do you go? How do you problem solve that? So whether you like it or not, that's part of your education now, right?
Well, I
Okay.
appreciate that. I'll give them a call. Thank you so much.
Yeah, no worries at all. Any other questions?
I have one, and we kind of already touched on it, so I'm so sorry.
It's okay.
So if we're looking at it and it says how many standard deviations below the mean is a certain number. So just let me talk you through it and tell me where I'm going, like what's going on.
Absolutely.
So I take that number, I get the z-score, and then I, from the z-score, get the area between the mean and the z-score. So far, so
Wait,
good?
Stop, right? So what the question was, how many standard deviations is this score from the mean?
Yes.
That's the question.
Yes,
Yeah,
yes.
like you literally, you don't go through all those steps. You literally stop there, right? So the question is, and I'm going to share my screen once again. So here we are, right? And so the question is, how many standard deviations is this 92 from the mean? That's the question, right? I'm just making sure.
Yes.
Verifying. So
Yes.
the question is, yeah. So all I have to do is write that. All you have to do is write 1.89.
Like you're writing the z-score number?
Yep. The z-score is the number of standard deviations from the mean.
Wow.
Oh,
Wow.
free.
That was, I felt everybody's mind blown right there. That was amazing.
Okay,
Oh,
yeah,
my
right. Yes. I am so sorry if I did not articulate that. Right. And so, and here we go. Like, can you guys see? There's Macklin. You want okay. So yeah. So I'm sorry if I didn't articulate that well earlier, but yeah, that's all. Like all a
He's
z-score
so
is
cute.
that individuals, the number of standard deviations that is from the mean. Yeah, right.
He's got a
Don't
color
feel
voice.
stupid at all. Never feel stupid for asking a question like that. Never, never, never. Because you're learning and all of you are here in this meeting. So you're actually doing your best to learn this material. So never, you know, never feel stupid. Sometimes I feel, I'm like, oh, you know, I need to really articulate that well, right? Don't ever feel stupid. Don't ever feel stupid for asking questions.
That's so
Doing
great.
it.
Thank you. That really cleared it up.
Right, good. I'm so glad I was able to clear that up for you. So, and then somebody asked, is exam 2, so Macklin's here, that's why I'm looking like all over the place. Is exam 2 based on homework 2 and 3? Yes, so exam 2 is based on everything after exam 1. So I can show you that. Macklin doesn't want me to though. He wants to mess with all of this. Sorry. Okay. So let me go back to web courses. Macklin's like, it's storming outside, Mom. What are you doing? This is scary. Can you guys see my screen? Did I share my screen?
No.
No.
All right, sorry about that. Let me go back. Okay. So here's our
Yes.
class. Yeah, so here's the modules. So exam 2 is going to be on everything from correlations. It's going to include reliability and validity. So those are all just like multiple choice questions. You don't have to do anything there. It's going to include significant testing and one sample Z and individual Z scores and one sample Z hypothesis testing. So it sounds like a lot, but all of these really kind of go together. It's like really, it's correlations is its separate thing, reliability and validity is its separate thing, and kind of everything from them on has to do with Z scores. But you're also learning the hypothesis testing, so that's really important as well, that you look at the steps in the hypothesis testing. So for example, sorry, I know I wrote these modules, but sometimes I don't know where I have things in the modules. Yeah, so kind of these steps in hypothesis testing are the steps that you'll be using through the semester. So this is hypothesis testing or a test of statistical significance. And so make sure that you familiarize yourself with these steps. But in general, we've got everything from, I hate it when it goes back to, from so correlations, reliability and validity, significance testing, and one sample Z individual Z scores, and one sample Z hypothesis testing. And then you have the study guides. Any questions? Yeah, no worries.
On the exam, will we be able to use notes again?
Yes, all the exams you'll be able to use notes.
Okay, yay.
Yes. It is helpful. I mean, you still, there's still so much to learn. I think this class is very much about like the procedures and what the numbers mean. So it's fine to use your notes.
I have another question really quick.
Of course.
Are we gonna have to upload the handwritten work again?
Yes. And make sure that, so I know we were pretty lenient for the first test if, you know, if it was hard to read or it was in, you know, the wrong format, but make sure that you take your picture and then either, you know, save your pictures as a PDF, but it's way easier just to copy those pictures or to insert those pictures into a Word document and upload that. And that way we know we can see them and read them.
Okay, thank you.
Yes, for all of the remaining 3 tests, so not the final exam, which is a bit different, but the 3 tests that you have, you will have to show your work, your handwritten work, by taking a picture and uploading it at the end.
Okay, I have one final question.
Okay. It better be the last one. I'm just kidding.
It will be, I promise.
No, you're fine. You're totally right.
So on the ones on the homework where we're like minusing, because it's like everything below, like I'm just making up a number, like everything below 98 or whatever
Mhm.
for whatever group, does it matter that the different groups have different means, or are we doing this from 50? Because it's like assuming a normal distribution, meaning 50.
Yeah, so assuming a normal distribution, so like the mean is always going to be the median in the middle. So if it's a completely normal distribution, the mean is going to divide the sample into 50-50 on each side of the curve, right? So the mean is just going to basically act like the median. So does that make sense? Maybe.
Can
Or
you repeat that one more time?
Sure. So if we're talking about a normal distribution, right, which you're just assuming for this test, for this class, right? So if we're assuming normally distributed data, the mean and the median are both exactly going to split the sample into 50-50, right? So always 50% of the sample is going to be above the mean in a completely normal distribution and 50% below, just like the median. So 50%. So if the scores on the last test for this class were totally normally, perfectly normally distributed, if you know the mean was say 88, then you know that 50% of the class scored above an 88 and 50% of the class scored below an 88. Is that helpful?
So the reason I ask is because like on the homework and the two groups, there was like, I did it on SPSS. I actually haven't used Excel, so worried about that. But I did it on SPSS and I did like analyze, descriptive, whatever, did all the things. And it says that each group has a different mean number. You know what I mean?
Okay, I think I get what you are worried about. So I'm going to show you my SPSS here just a minute. So you've got two samples. So each of these samples is to be looked at differently. Right? So if I ask you about the 91 for participant 1, then that mean and that z-score is different, right? Like, you treat them as two completely different samples, which they are, right? I mean, I don't know if I'm making sense, but if I ask you about this score, you only answer for using this z-score, using the means for this sample, and you totally ignore what's going on with the other sample. Does that make
Right.
sense? Yeah.
But if it says normally distributed, then on those ones where we have to like minus or add, you know what I mean? We're using 50 and not the means given, right? Or no?
Well, the mean is, yeah, so the mean is always whatever. So if this is a normally just distributed sample and the mean is, I forget what it is, like 82, let's say, who cares, right? So
Yeah. Just not 50.
so
Anything, yeah.
that 82 is going to divide the sample into 50% above 82, 50% below 82. If the mean for this one is 98, right, then 50% above 98, 50% below 98. If you have a sample of zygons, right, and the range of data is between 1 and 1,000,000 and the mean is 162, then the 50% are going to score below 162, 50% are going to score above 162. Does that kind of help?
So we're minusing it by 50%, not by the actual, like, not by like 98.00, whatever the mean is.
Right, no. Yeah, exactly. So
okay, I got it.
Yeah, right. So whatever the mean is, it's going to be 50%. Yeah, go back to the whiteboard, right? So whatever this mean is doesn't matter. Literally doesn't matter. It's going to be 50% above whatever the mean is, above and below whatever the mean is, right? And so now you're just dealing with percentages, right? So you're ignoring the means and the sample standard deviation. Now you're just looking at, okay, there's this percentage, there's this percentage between the mean and this z-score. right? So you're only dealing with the percentage, and 50% is above the mean and 50% is below. So we can add and subtract from 50% without even knowing what the mean is. Does that make sense?
Yeah, I think I got it.
Okay, good, good, good. You know, and sometimes you kind of have to sit with it and play with it a little bit before it really kind of sinks in. But I think you're on track. Like, you're asking the right questions. So I think you're getting to wrap your head around it, even if you're not totally comfortable with how we talk about it and approach it and stuff. And you can always ask me questions, you know, and Soli's in this meeting now. I mean, you've got some great UTAs in this class who've been there where you are before, you know, and if she can help you, I'm sure she will. And if she can't, if you ask a question that, you know, she's not really sure how to approach, she'll definitely get in contact with me. So, yeah. Yeah, and see, I mean, what would we do without Soli? She's so amazing. You know that I don't ask her to do these like lesson reviews and wonderful videos she makes. She just does them all by herself. She's amazing. Yeah,
And they
Letitia,
were really helpful last time.
so good. Yeah,
Thank
yeah.
you guys. Thank you. Thank you, Professor. Thank you guys. Honestly, I'm lucky to be passionate about learning. I just like it. I love learning, and I want other people to look at learning the same way I do. So any way that I can help, I will. I'm happy to.
So, well, we're really happy to have you as a part of this. I know that I am. I'm just, you know, like I feel so lucky every day, you know, when I'm talking about you. But yes, so somebody asked a question. Oh yeah, so somebody was saying that the wording kind of confuses her at times. So that was Letitia, and that's just it does for everybody. For starting statistics, I know that. For me, you know, I mean, we use some bizarre language like failed to reject the null, and you know, the language that we're using in this lesson too. It's just a matter of practice. That's why is I think that it's so important to spend your time studying for this class. You know, otherwise the wording can really trip you up. But you know, it's just a matter of practice, and you know, certainly, you know, you're here doing the right thing. You know, coming to a meeting that's voluntary. So you'll definitely get there. So.
Thank you. That's a lot of faith in us.
I 100% have that faith in you. You know, I mean, if I can do it, anybody can do it. You know, like I was not a mathy person. I was always, believe it or not, I was literature and language and didn't feel very good about math, but in psychology, you know, I had passion, and because it was applied in a certain way, I could understand it better. But I understand that apprehension that comes with, you know, approaching a math class and, you know, kind of dealing with all of these numbers and formulas and technology and everything. So so I know that you can do it. I did it. Students before you have done it. Soli did it, right? All of your UTAs did it. So you can do it.
Definitely.
Just
And math is not my thing either. I don't know if you remember this, Dr. Witten, but when I took your class, when we did our intro slide, I put in there, I was like, I'm so intimidated and nervous to take this class, but I look at things as a challenge. So hopefully it'll be
I
great.
do remember
Yes.
that actually.
And then I was
yes,
like, at
because
the
I
end
loved
of the
that.
semester, I was
look at
like,
things
yes. You know, I felt
and
like a
you know,
gladiator.
yeah. So Soli did amazing in this class. Obviously, she's here too. And Valerie burned her last stats book, not mine, but the one before that. I don't know if you guys were there, like your other UTA, like was really adamant about never taking another stats class. And then, you know, she was told she had to get this major, and she was like, I guess fine, you know. And
Ooh, this is my story.
Yeah, enrolled in my class, and she did okay too. I think that, this
But you
level.
know what? We did exactly what you guys are doing. We showed up to the meetings, we asked questions, we showed concern. Like it's all about the effort that you put in. And if you're putting in the effort, you're gonna do great in the class. There's no way you can't.
Yes, I think absolutely I second that, so thank you, Soli. Okay. Wow. I think
Did you
that
want us-
dramatic silence means that
Yeah.
it's time to wrap up. So I really do appreciate everybody who came here today. I like, as Soli said, I mean, this is the way that you learn, by asking questions, by coming to meetings like this. And I just really appreciate it. I appreciate all of your questions. They help me connect with you as a class. And so I really love it. So we will do this again. This will be our thing, Fridays at 3. So I'll be here again next week. And in between now and then, if you have questions, you know how to get a hold of me, you know how to get a hold of your UTAs as well. So I think that's all, folks.
Thank you for having these. I super appreciate it.
No
Yeah,
worries
thank
at all.
you.
Thank you all.
Thank you.
Thank you so much. Have a good weekend.
You too.
You too.
You too, and your cats.
Thanks. Bye.